Hello guys, welcome to my channel. This is video number 8 and we're going to be covering constraints in SQL. And the first constraint is a not null value. And this constraint would ensure that a column cannot have a null value. And so a not null example looks like this. When we're creating a create table student, and then open parentheses student ID int not null, and which means that a student ID cannot be just blank. It needs to have a value. This is what we're saying by putting a not null constraint in our for the student ID value. So student ID will always have a value. That's what we're saying, and the last name as well. So the last name cannot be left empty or would have a value, and first name as well. And this is what it would look like. The null value in a statement, it looks just like this. And when we're doing alter table student, so when we are altering or we're changing, if let's say if a student, if the last name was null, then if we're changing it to not null, then this is how we'll write an alter statement. Alter table student, modify address, not null. So this is for the address, but if we wanted to modify the last name, if it was null, then we'll just modify last name, not null, and this is what it would look like. So the second constraint is the unique key constraint. And this unique key, just like its name, it ensures all values in a column are different and they're unique. So you can have many unique constraints in a table, but you can only have one primary key. We'll cover primary key in detail later on, but the unique key query would look just like this. If we're creating a table for the student, and we'll write student ID, and of course it would not be blank. That's what we're saying by saying not null. And then the unique key will make it every student ID will have its own unique value, which will not be repeating, and each student would have a different value. That's what it's saying pretty much. And this is how you would write it, and this is what it would look like. So not null, and then if we're declaring the student ID be unique, then we're just writing unique next where the student statement is. And if you want the first, well, we can't have a first name unique because everyone's name is, of course, unique, and sometimes it could repeat as well. So that would not be possible to do that. But you can just put unique statement for the IDs and things like that that would have different values for everyone. So another example is altering table student, and then you add unique student ID. And another one could be, dropping constraint. And if we're dropping the unique constraints from the student ID, then we don't want any more unique, if we don't want any unique student ID and we want to drop it, this is how a drop statement would look like. You would just do alter table student and then drop constraint, and UC underscore, UC is for unique key, and then student ID. So if you're just dropping the student ID unique key, this is how you would write it. So we covered that, and now we're moving on to the primary key. Number 3, the primary key. It's uniquely identified each rows and records in database table. So in order to have our primary key, the column cannot be null. So it has to be not null before it could be defined, which means that a primary key always have a value, cannot be blank. So basically, primary keys, both unique key and not null constraint, enforced together in one column. So example code looks like, so we're writing alter table student, and we're adding a primary key constraint to student ID, and we are going to be writing add constraint pk for primary key underscore, then we're adding primary key to student ID, so we're adding student ID, and then primary key, we're just declaring the primary key. So yeah, so adding constraint, we're just declaring the student ID. We want it to be a primary key. So we're adding this primary key to the student ID, and this is what it would look like to write an alter statement and adding primary key. So the fourth one is foreign key. Foreign key is uniquely identifying rows and records in any other database table. And it also establishes relationship between two tables. So the table containing the primary key is called child table, and the table containing a candidate key is called parent table or reference table. So let's take a look at this query, and this is what it would look like. Create table student and student ID, not null, primary key, first name varchar 50, not null, and then the class ID is a different table. So we're assuming that we have two different tables, and we're joining them by using the foreign key. So this is what we're going to do. This class ID came from the class. Let's assume that came from the class table. So the class ID is foreign key reference, and then we're referencing the class here, and it's inside the class table, and this is our column class ID. So we're adding foreign key to the class ID in a different table. So this is what it would look like when we write the foreign key. Another example would be here, like create table student, student ID, and first name, and then class ID int, foreign key reference, and then we're writing class and class ID, like here, similar to that. And so the fifth one is a check constraint. This ensures all values in a column satisfy certain conditions, and we use check constraints to validate data. So this would apply, works hand in hand with a business rule. So now let's say our business rule tells us in this case that the age of a student who wants to register must be 18 years old or over to register or to qualify. So in order to write the query, this is what we'll do. Create table student, and we're declaring an ID, student ID, and then last name, first name, age. And the age is int, of course, and then check, we're writing a check constraint here, checking age of a student is greater than or equal to 18. This is according to our business rules. So the check constraint comes handy when it comes to validating a business rule. Just checking to see that the age is indeed 18 and over. So the sixth constraint is a default constraint. This provides a default value for the column when none is specified. When we don't have a value for a column, then we're declaring that default value will be assigned. So when we're creating a table student, we're taking this example again, and agent. Now, when we have the city where the address of the student is left blank, then we're asking to be a default value of Texas or Illinois, whatever value we want to be replacing that blank value. So if the field in the city is left blank, then the default value would be Illinois in this case. And this is, you run it, and this will be it. So this is it for today, and next week next video we're gonna cover, actually we're gonna try to create tables together and apply these constraints and see how they would work and how they can help us populate data easily and combining tables and other other things that they can do. So thank you for watching, and I'm also going to leave this information in the description area. Make sure you copy it into your management studio, maybe experiment with it and see if you can run it and so on. So since we have the student table, then be able to run some of it and see what it does.